we've only got one gentleman here that's had to deal with a VRF system before. Does anybody in the room have mini splits in their building? Those one-to-one, got some here, one-to-one applications. So there's kind of a difference. I don't know if I'm doing this right. Maybe not. There we go. So there is a little bit of a difference between the two products. And here's what we're going to cover today. Basically, I want you guys to walk away with an understanding of how VRF started, what are the different pieces and parts of this stuff that are going to be applied to your building. Now, we're not going to get into the weeds of truly the mechanics of how this stuff operates. I can be happy to do that with you later. But my goal is for you guys to walk away with an understanding of the pieces and parts, how they react to each other, and what are some of the things that you guys need to be aware of in terms of engineers that have to deal with building issues or owners and operators of buildings, and how VRF may affect you guys. So we're going to cover some of those things, as well as some of the control options that we've got, and obviously from your guys' perspective, since we've only got one guy in the room, how and when to apply VRF to your buildings. So let's take a look at some of this stuff. So VRF, you're going to hear two terms in this market sometimes. You'll hear VRF and VRV. They basically stand for the same thing. We're talking about variable refrigerant flow or variable refrigerant volume, okay? And all that's happening is we've got a gizmo outside here that's kind of like your heat pump at your house, okay? Some of the differences that happen in this gizmo versus your heat pump at your house is you can connect to several different indoor units, okay? But basically, this thing is a big glorified heat pump. So we'll try not to overcomplicate it any more than that. And that's what they're talking about. These indoor units control temperature in the space by varying the amount of refrigerant that flows through them. And that's how this system got its name, variable refrigerant volume or variable refrigerant flow. So right now in our market, we've got a few different manufacturers happening. Rex talked about, we've got LG, Daikin, and Mitsubishi are kind of the one tier of manufacturers, but we've got a lot of folks that are just recently entered this market. Trane's co-marketing a Samsung product. We got Panasonic and Sanyo, Toshiba, we got Hitachi in this market. So we've got a lot of different vendors, which really creates a confusion for folks who haven't been exposed to this kind of technology very long. And so one of the things you really have to be comfortable with is whoever is kind of guiding you through that process. So whether that be your manufacturer's rep or that be an engineer that you're comfortable with or whoever, Design Mechanical here has got a lot of folks that are knowledgeable about this product. So you want to make sure that you know that the folks that are guiding you through this forest know what they're doing. So let's take a look at kind of the history of VRF. It was invented back in 1982, first inverter-driven system in 1990. Just to get a tech sense of where we're at, raise your hand in this room if you know what an inverter drive is. We've got some folks yes, some folks no. No big deal. Inverter's like a gas pedal for an engine. And lets it go faster and slower is all it is. So simultaneous heating and cooling of VRF in 92 and first 410A in 2003. It didn't get here until it was already 15 years into the making here. And then just recently been re-engineered with new stuff. So really the goal of this is for you guys to get a sense that not only worldwide, where it's been going for 20 years, here in the United States it's not new stuff because we've been doing it for 10 years here in the United States. We've got a lot of projects on the ground here in Kansas City of many different manufacturers so that you can become comfortable with what we're looking at here. So duct-free splits is one aspect of this. You guys have some of these in your buildings, cooling computer rooms and things like that. There are different heads you can get on them. You can get them where they look like a picture frame. You can get them where they look like a four-way ceiling cassette. All kinds of different things here. We can even get them in the high static ducted. Another tier to this duct-free split system is a multi-split. Now what this means is you've got a few different heads connected to the same outdoor unit. It's not in a piping network. These are home run back to that outdoor unit, okay? So the duct-free multi-splits, you get a few different fan coils that you're allowed to hook to them. The reason why we kind of draw a distinction between this duct-free side and what we're going to kind of here to talk about today, and that's the bigger VRF equipment, is they communicate differently, and this is true for all manufacturers. They communicate differently. If you want to include them on a BMS system, it's going to be a different set of criteria that you're going to have to go through. So that's why there's always kind of a line in the sand between the duct-free split stuff and then the VRF stuff, which we're here to talk about today. So we've got basically, we said we've got a big outdoor heat pump out there. You can connect to, you see here, from 13 to 72 indoor units. They go up to 42 tons, depending on the manufacturer you're dealing with. So you can really get together a big system of these units. But the kind of the foundation of this thing, the thing that if you're talking about VRF that you have to be able to distinguish between is heat pump versus heat recovery. And so we're going to give you kind of a skim through overview of what the difference is between heat pump and heat recovery. So this is a heat pump system, and we have our glorified heat pump out there. We have several different indoor units connected to it in here, okay? And you see that we have two pipes running through all of it. Now, no matter what manufacturer you're talking about, this diagram is going to look exactly the same, okay? It's two pipes to all of them, and the choice between heating and cooling is made at the outdoor unit, okay? That means every one of these indoor units, while they can all have different set temperatures, maybe some guy wants it 65, the other guy wants it 70. If they're in heating, the guy that wants it 65, his valve just goes closed. The guy that's 70, his valve stays open until his room warms up, okay? And so that means that they all switch. It's like a two-pipe boiler chiller system, for those of you that are familiar with that. So that's a heat pump system. The other type of system that you have with VRF is heat recovery. Okay, this is kind of where the manufacturers sort of veer off into all different directions, and you got different configurations. But basically what it means is instead of the decision between heating and cooling happening at the outdoor unit, that decision happens right here at these magical little boxes all throughout the system. We call them HR boxes. Mitsubishi calls them BS, or branch controllers. Daikin calls them BS boxes. So really all it means is that the valve used in switching from heating to cooling is in that box. Okay, so for every one of these boxes or every one of these ports on a box, you have an independently operating zone. So that means I can have all of the fan coils, the way this is laid out, all of those different fan coils, even though they're hooked to the same heat pump, can all be in heat, they can be independently be in heating or in cooling at the same time. Okay, so I have independently operating zones. One guy's getting air conditioning, the other guy's getting hot gas heat. So piping the HR box is another way that the manufacturers differ a little bit. You can either pipe them in parallel or you can pipe them in series. There's one manufacturer in town right now that can do both, but because these different piping methods, you're going to get fundamentally different decisions that have to be made in terms of how to lay this stuff out. And let me show you what I mean by that. So if you're piping in parallel, this is kind of the layout that you would be looking at. A lot of individual boxes feeding a lot of individual spaces. If you can pipe in series, you might have one box like this, maybe another big box that's piped in series. Or if you're doing both styles of piping, then you can kind of branch out and feed the spot. And this is what I'm talking about when I'm saying that as you get into the heat recovery side, that's where different layouts come into play. Some folks' boxes need condensate, some don't, some are bigger than others. And so designing around one system when you're talking about heat recovery starts to become something that has an impact to building owners and building end users. So the neat thing about this is if you have a heat recovery system, and I got one guy on one side of my building that needs air conditioning, the other guy on the shady side of the building needs heating, that means that those guys basically are exchanging energy back and forth across the building. So the outdoor unit doesn't have to do all that much work in a heat recovery system, and you can become very energy efficient because you're just trading that energy back and forth across that building. This is kind of a driving reason why engineers are looking at it, building owners are looking at it, because these systems become very energy efficient, especially when you're able to set this transfer of energy up across the units. So pieces and parts that you have to deal with. We've got a couple of different criteria. Number one, we can do ductless, and all that means is there's no ductwork involved. The only thing running to these things is refrigerant pipe, and so these things will sit in the space. This is a traditional 3-foot long, hangs on the wall mini split style, but there's lots of different styles. Almost all the manufacturers have very similar style of fan coils. So they'll all have one that kind of looks like a radiator sit in the corner, and then you have some that are designed to go up into the ceiling. 1-way, 2-way, 3-way, 4-way blows. The neat thing about these air handlers is that means that they're in the space. So you gain the energy efficiency of getting the energy right to the space that it's serving. You gain the ability for your maintenance staff to not have to dig through ceiling tiles and crawl through all kinds of different places to get to the filters that need to be changed. And so if there's a problem with the unit, it's all right there to deal with. So you're not having to hunt through different stuff to be able to deal with problems. So it's a very efficient way to deliver energy to the space, and it's a very efficient way for a building staff to have to maintain units that treat a space. We are America, and America loves its ducted units. We love to not see anything that's keeping us comfortable. So VRF understands this, and they offer quite a wide line of ducted, traditional ducted style units. We've got vertical upflows as well as horizontal blow units. And in fact, some of the manufacturers now have made the understanding that even the ducted air handlers that they are offering don't quite cover the wide gamut that's necessary in the buildings that we're seeing today. And so some of the manufacturers are offering an option where you can connect an electronic expansion valve and a communication module to a VRF outdoor unit and provide a refrigeration coil that's in maybe an existing air handler that you have in your building, an air handler that has anywhere from a 4 to 16 ton coil, or maybe it's got a coil that's bigger than that, and so we're putting a couple of these things in and feeding that. Because the air handlers coming from almost any VRF manufacturer, they kind of max out at 1 inch of static. So if you have a very big system or a very big air handler, a lot of times you're going to need more than that. And so that's kind of where we see these kits coming into play. So it makes it a very versatile system. A lot of different ways you can put these pieces and parts together. Electronic expansion valves are in all the units. The only reason I talk about this is because fundamentally VRF controls temperature in the space differently than any other system that we're all used to. Every other system that we're used to, if your space gets too cold, a signal gets sent to a compressor or something outside, it kicks on, runs full speed, and floods that coil, air blows over it until the temperature gets better in the space, right? So with VRF, it's kind of always having refrigerant flow through that coil, through that little expansion valve. Now, we can get into the technical neat things about that later. The neat thing to building owners and to building occupants means that those environments are drier because there's always a little bit of cooling going on instead of hurry up and cool it down and then let it heat up and then cool it down. So that means you have a drier environment, a more stable temperature environment, and that creates higher comfort in those environments. And so it's an added benefit in terms of when you're existing in those environments. One of the things that we noticed, as Rex said, we have a live lab, our office is VRF. And one of the things that we all noticed, being a bunch of hot-blooded guys, is that we love our houses to be in the 68-degree range. And because our office is drier than what our houses are in the summertime, we noticed that 72 is pretty chilly in our office working with VRF because it's always drawing moisture out of the air. So it's been interesting to experience that. So if you have a system that's composed of all these different EEVs, providing all these different levels of refrigerant flowing through all these different coils out there, you probably have to have a fairly complex, albeit heat pump, outside to be able to deal with that. And there is, and we can go through a lot of the issues of the complexity of that, but that's not what we're here for today. The biggest piece that I want you to understand is that it's inverter driven in terms of its fans and its compressors outside. You don't have to know a lot about inverters, but if you know this, if I only want to go 5 miles an hour, if I have an inverter compressor, then I can push on the gas and just go 5 miles an hour, nice and even and slow. With a traditional system, if I wanted to do that same thing, I step on the gas full until I get to 5 and then take off the gas, and then step on the gas full and take it off until I get to it. And so that's the difference in energy savings when we're talking about inverters versus traditional systems. If they're both running flat out, they get about the same energy efficiency. LG or Daikin or anybody in VRF doesn't have all that impressive energy numbers when we're talking about running flat out. It's when we're only running part loads that the energy efficiency comes into play. And so what's that look like for folks that have to deal with buildings? Well, here what we've done, this is a independent directory, www.ahri.directory.org. They have independently rated all of the VRF manufacturers across several different criteria, in several different operating environments. I encourage you guys to go look at it if you're interested. But basically what we did is take a look at efficiencies, IER, which is part load efficiencies. How efficient are these systems when they're running at that part load? Not running full tilt, but only a spring day, a day like today, where it's not super cold outside, it's not super hot. The building has to run, just kind of maintain, and the efficiencies that we get. And this is where it really stands out, where VRF really stands out. So let's bring this back, because a lot of you guys probably don't have any idea how to transfer efficiencies into money into your pockets. So let's take a look. What I'm going to use is an energy modeling software. There's several of them out there. This one happened to be Energy Pro, and we looked at a building, okay? So here is a building, 11,000 square foot, rooftop package VAV, and we're comparing the energy efficiency of that system versus a VRF system, okay? So that's what we're looking at here. At 10 cents kW electrical cost and $1.30 natural gas cost. They range widely as you travel the United States. This is just where they set it at so we could make a comparison. And what you're seeing here is the same building if it were in the environmental conditions of New York, the environmental conditions of Atlanta, of Phoenix, of St. Louis, okay? So obviously everybody has different seasons, different times, and so this is the kind of cost savings that we see when we start to compare VAV system versus a VRF system in this example building across those different markets. So you can see when we're talking about VAV, it's nearly a quarter savings, 25% savings across a VRF system. So this doesn't include the difference in how these systems operate, how these systems maintain. This is just energy efficiency. So this reason right here is one of the reasons why we see most engineers nowadays, it seems like, one of the very first things they ask themselves is this building a fit for VRF? Because of its ease to install, its ease to maintain, and its energy efficiency. So we're seeing a lot of folks look at this for this reason here. So, well, that's all great. It's going to save me a bunch of money. How much is it going to cost to put it in? So these are some of the things that we get asked. Heat pump versus heat recovery. Remember, heat recovery's got that little HR box extra piece, has 3 pipes, so it's going to be a little bit different cost per square foot. But here's some, and these are in our market. This is what we can typically see a system getting installed for. Not just the equipment cost, but what it's going to cost the end user to have the gear installed. So between 12 and 16 bucks a square foot on heat pump and 14 to 20 on heat recovery. So it starts to be a very cost-effective way to look at these buildings. Now, obviously, that's a big range, and some of you guys are going, okay, well, how do I know where exactly in that range my building's going to fit? There are a few different things, regardless of the manufacturer that you're talking about, they're going to affect some of these costs, okay? Number one, how many FCUs, fan coil units, how many indoor units are you going to have per ton? You know, if I've got an office space and every tiny little cubicle office has its own fan coil, well, that's going to be a high dollar per square foot. If I've got lots of big open rooms like this, where I could have one fan coil treat this whole room, and if I have several rooms like that, well, then it starts to be a relatively inexpensive price per ton. Number of control zones, and that means how many spots do you independently get to choose to be in heating or in cooling at the same time? And then retrofit conditions. A lot of us are up against buildings that are nearing the end of their usable life in terms of their boiler chillers, where they're not going to have to replace water piping. And so how easy is it to get this stuff back into those same spots? The nice thing is that we're dealing with a lot smaller stuff, but it still doesn't eliminate some of the troubles of designing around buildings that, you know, were never engineered in the beginning to have fresh air in them, never engineered in the beginning to have air conditioning in them, and they've only been retrofitted back with some of that stuff. So it always creates unique problems. We're not going to spend a ton of time on these couple of slides. The biggest thing I want you to take away from these is these systems are modular, okay? They go from 6 tons to 42 tons with any manner of combinations of units. And so your footprints on the roof kind of look like this when you're grouping these units up. Not very big footprints. It is amazing how much or how little square footage on a roof you can put 30 tons in. The other neat thing about this, because of that whole gas pedal thing on the compressors and the fans, it is amazing how quiet these units are when you're sitting right next to them. Does anybody deal in buildings that have access to the tenants to the roof? You do? So I've got some folks, even though their VRF systems are on the roof, they still, on the other side of the roof, have a roof patio. The VRF systems don't bother the tenants enjoying that roof patio because of the noise. Depends on how it's laid out. So piping capabilities, we can go a long ways. I'm not gonna give you a quiz over this stuff, but really, they can be 360 feet level difference. We can have a total of 3,200 feet of pipe in these systems. Basically what that means is we've got a 10-story building right here in downtown Kansas City that is complete VRF from top to bottom. We've got all the units on the top of the building, feeding the floors all the way down. So that's really all I want to cover with the piping is we can go a long way side to side. We can go a long ways vertically. These systems can have a lot of pipe in them and still do just fine. All right, controls. All the manufacturers have zone controllers. Basically, the wall stat that you use to interface with the actual fan coil in the space. A lot of different features are available with those. What we'll talk a little bit about is group controllers. Everybody in our market right now has a version of this. Okay, this is a proprietary central controller, and what's neat for building owners about this is this gives you a BMS system for that unit. For us is $3,000, and we're priced comparably to everybody else. The wiring needed to operate this, almost all of it is already in part of the actual existing system. So that means that you can have a spot on any computer that you can go and hit and see how your building's doing. You can have somebody emailed if there's a problem with the building. You can see temperatures in different spaces. If somebody's complaining that the room's too hot or the room's too cold, you can dial in and see what set points the room are actually at versus what the room temperature is. So a lot of control is available with all the VRF manufacturers through a very little cost when you're dealing with the proprietary controllers. And that is another shift that we've started to see in this market, is that people are taking a serious look at these proprietary controllers and asking themselves the question, what differences between that and a true BMS system are there? And are those differences worth the $50,000 or $100,000 cost difference that there is between the two? So this has been an interesting thing playing out in our market right now. Obviously, we can connect a VRF system to a traditional BMS system through gateways, LAN, or BACnet. Either way, that stuff is available. Another neat thing, especially for building owners in terms of control, remember we talked about every fan coil has that expansion valve? That expansion valve for us has got 1,400 positions, which means the average pipe coming to an indoor unit is about 1/4 inch. We just divided 1/4 inch by 1,400. They have very precise control over the refrigerant flowing through that coil. That's boring talk. The interesting part that I'm getting to is we can measure the power consumption happening at the outdoor unit and divide that power consumption across the indoor units. Proportional power delivery. What that means is, at the indoor units, all it is a tiny little fan, doesn't draw much power at all. Most of the horsepower of these units is out here at your outdoor unit, okay? So what that means is if we're dealing with a building where the owner doesn't want to pay for the power consumption of the outdoor units, we can write into the lease agreements this formula that divides the power out, and now the tenants can pay for the power consumption that they're responsible for of the outdoor unit. So we're seeing condo projects. We have had a few in the area that have looked at this in terms of ways to make this make sense for their buildings as they go forward. So this isn't just an LG thing, and I know the other manufacturers have different versions of this very same thing. So this is something that VRF is able to offer, not just LG. So it's becoming a very attractive thing, not just condo projects, but even school campuses, trying to figure out who's using how much power for what and divide it across the different departments, things like that. So a lot of different uses for this technology, but it's a neat thing that is kind of already inherently built into the way that VRF is designed. So why use variable refrigerant flow? Here's another reason. We'll look at this. Okay. And we won't get caught up in the tonnages, but if you want to transfer energy to the space, here's a representation of how big your air duct would have to be. If you're going to do it with water, here's how big your water pipe's going to have to be. And if you're going to do it with refrigerant, here's how much refrigerant pipe you need. The reason that any building owner or building management guy cares about this is when you get to this picture. When you save the amount of space that is required for the different pieces in a boiler, chiller, air-driven system, you can now make the floors smaller if you're talking about brand new construction, because they don't have to be as tall. You don't have as much big duct work required going down the floors. You also get the basement is now leasable space, or at least storage space. A lot of schools look at this project because they end up getting a whole new section of storage space because they get to clear out their boilers and pumps and skids and all that stuff that's using up some of that usable space. So you now get to have some very usable space down here. So that is why when you're using VRF or using refrigerant to transfer energy to the space versus water or air, people from even a building owner's side of it are looking at it from that perspective. So we've gone through some of this stuff, but here from a building owner's perspective, obviously lower utility costs, okay? That's a big one. That's a big one that's driving energy in terms of engineers looking at this product. But also this is another big piece of it. Maintenance costs. At the end of the day, these things are just heat pumps blowing across fan coils. So all we've got is filters and cleaning our coils outside. We don't have a complicated water system with VFD pumps that have to be maintained by, you know, a truly technical professional, because they have to know how all these pieces interoperate together. A VRF system, all that stuff, all that engineering's happening inside that glorified heat pump outside. You just got to keep the coils clean, make sure your electrical connections are tight. That's the maintenance on this stuff. Building costs, you know, the gear weighs less, it's smaller, it takes up smaller footprints, so you're saving building costs. A lot of you guys are looking at retrofit stuff anyway, so this isn't as big a deal. But this thing, even in a retrofit, saving on leasable space, or even if you can't turn it into another unit, you can turn it into storage for the units that you have and make the spaces more attractive. So we're seeing a lot of these different things drive owners towards VRF. So let's look at the other side of the equation. Why would your tenants care if you have VRF? And here's some of the different things. We talked a little bit about this, that the individual zones become more comfortable. You have the ability to individually zone so many more spaces with VRF than you would a traditional system. That means so many more people get to have the independent decision to heat or cool in their space. Now, anybody in here that has to operate buildings, any of you guys that have to service buildings know that you're never going to have a building full of happy people. But what you can do is offer more control of the spaces they operate, and I'm not going to say it makes them happy, it just makes them less mad. That's what I've learned from dealing with schools and things like that. And that's about all you can hope for, is that they're less frustrated with you at the end of the day. Another neat piece of this is after-hours operation. Because our outdoor units are modular, so there's several operating in a single spot, and to that gas pedal effect, if we only have 2 guys come in and want to have heating or air conditioning after hours, I don't have a big chiller system that has to fire up and figure out how to part load for just a 2-office section coming in and dealing with it. We're able to scale down and scale up as use happens in that building. Quiet operation, again, Rex gave you guys the invitation. I'd love for you guys to come out. It is amazing how quiet 16 tons worth of heating and air conditioning are when you're standing right next to it. We can have a conversation with me talking at this voice, and you'll hear everything we say. So it's really quiet. And because all the operation happens outside, inside it's a little 2-amp DC fan. So just no noise from the indoor units. Very quiet system, lower utility costs, and maintenance is a simple and easy prospect. There are a couple other pieces of VRF that I want you guys to be aware of so that you kind of have an all-rounded out view of it. The first one is that VRF equipment also comes in water equipment. Now, to say it's water equipment may be a little bit misleading. It's really kind of a hybrid system between what most folks think of a water system, where it's water all the way through, and a DX system, okay? So instead of these outdoor units, we'll call them that, really they're inside, instead of these heat pumps having air move over them to transfer energy, these heat pumps have water move over them through a boiler and chiller tower system, okay? From here on, it's all the same as any other VRF system. All the same fan coils that we saw, all the same options, all those things are available. Excuse me, because from here on, it's a DX 410A refrigerant system, okay? So it's just this refrigerant management station, this side, that we see. So if you have an existing boiler chiller plant that's nearly tapped out, this is a great energy efficient way to maximize the BTUs that you have left in that system and transfer them to new spaces or developing areas, whatever you've got going. This is a very energy efficient way to do that. We also see a lot of folks that deal with buildings that are in colder climates will go to this type of system, because now, even though VRF technology will function down to -13, it can get cold enough. You don't have to be too far north of us before your design conditions are colder than that. And so we'll see them use these water systems when they're up against that kind of thing. So that's something that's available. The refrigerant management stations here would then be mounted inside. It'd look kind of like this. You'd have a rack of them inside in a small mechanical room, maybe one per floor as you go up through a building, so that water piping just runs that corner of the building to each mechanical room, and then on each floor, you've got refrigerant piping stretching out and serving each space. So water systems is one of the things. The other thing that you need to be aware of is when you're dealing with VRF systems, that typically means that your outdoor air is decoupled, okay? Your fresh air is typically decoupled from a VRF system, and it's provided at room neutral. So a lot of different ways to do that. You can have an outdoor ERV or dedicated outdoor air system that provides that room neutral air to the space. Sometimes folks are thinking, well, if I've got to run ductwork to get my fresh air to the space, and I'm not really saving anything. Well, the difference is that instead of having a duct this big, because we've got to take care of the heating and cooling requirements of that space, now we only have something that just gets the 15, 20, 100 CFM required of fresh air to that space into the area. So it becomes a much smaller piece of ductwork going to the area. But there's lots of different ways to deal with fresh air when you're talking about a VRF system, and we can get into the weeds on that with you guys if you want. But the best way, the way that you're not going to ever have any trouble, is if it's a dedicated system that's decoupled and serving the units. Oh, and that concludes the entirety of the presentation. So does anybody have any questions? I know it's kind of a whole bunch of information.
You said that they work down to -13 temperature?
Yeah.
Is that centigrade or Fahrenheit?
That's Fahrenheit.
What's the efficiency rating?
That's a good question. Here, let's take a look at that. I actually got some slides, I think. Back in here. Oh, okay, yeah. So the question was, this is a heat pump. Really, 13 degrees, it's going to operate. How efficient is it going to be down there? Well, first let's take a look at, will it operate down in that range? So here again, I've done, and this is ahri.org, that same spot. Another one of the tables that they have that you can compare all the manufacturers across on is what is its heating capacity at 17 degrees. Or, I'm sorry, this one's out of the catalogs. My bad. The next one is. This one is out of each manufacturer's catalog. What their catalog says, that how many BTUs they can give you at different heating points, okay? So this is how much heating capacity in tons can a 6-ton unit give at these different temperatures. Now, right now, you see that we get, and for those of you that don't know, a 6-ton unit is 72 MBH worth of heating. So 72 right here, that line, is how much a 6-ton unit should be able to give you. And so we see, as you start to drop below, where are we? As you start to drop below that 4 or 5 degree range is where all the manufacturers start to slide off what we would traditionally think of as a 6-ton unit, and that'd be 72 MBH worth of heating. So, but you can see some manufacturers do better than others, but all the manufacturers provide heating at these cold ambients. And so if the system is designed properly, it can function very well in our environment. To your question, okay, that's awesome. It gives us this heat, but how much is it going to cost me? I'm not sure where I got a point to make it make it work right. Okay, so this is from AHRI. This is efficiency. Okay, we see that we're in the 2.5, 2.4 efficiency rating when we're talking about, this is tonnages, different sized units as you go across here. And then this is the COP, and this is these units operating at 17 degrees. I didn't pick the temperature, AHRI did, but this is the rating point. 17 degrees, and we're comparing efficiencies of the different sized outdoor units to each other. So no matter who you're picking, you still have pretty decent efficiencies in terms of heating, because you're up in the 2, 2.3, 2.4, 2.5 range. So they do provide good heating at efficient temperature, at efficiencies.
On your remote unit, do they have the like emergency heat or a heating coil within them?
Not at the outdoor unit. Typically what people do is, if they are nervous that they're not going to get the heat they need, they do a couple of different things. They'll either put a heating coil relay in the indoor unit, so that if my indoor temperature gets below X, he asked if we don't get enough heat at our indoor units, how can we make up for it? And there are a couple of different ways. Number one, you can put a relay at your indoor unit so that if your temperature inside gets below X, it kicks on baseboard heat or a duct heater or whatever we engineer into that solution. Another way I've seen people do it is they'll put the outdoor units, the air-cooled outdoor units, inside and duct air into them and discharge air out. Now, the thing you have to bear in mind is whatever room you're putting them inside, that room's outside. It's outdoor conditions. So be aware of that in terms of water piping in the walls or things like that. But then they just heat that room to 5 degrees or 0 or whatever cutoff they want. And so we see them doing that way. So lots of different ways to mess with that question.
In cooling mode, don't you have to deal with, at each terminal unit out in the office area, don't you have to deal with condensate? Getting rid of that?
You absolutely do, just like any coil doing.
Have a pump
Yep.
out into a drain, all that has to be set up for each and every box, right?
For each and every fan coil delivering cooling.
Right.
That is correct. Whether it's the duct-free, which are in the spaces, a lot of those have condensate pumps built into them that are designed just kind of to get it up into some gravity-fed system going, to some common drain. Or if you've got the ducted air handlers. I'm not very good at this. He said he was asking about condensate and whether the units needed condensate pumps, and that's absolutely a true statement. Any fan coil in the building delivering cooling is going to create condensate, and some of the units have condensate pumps built in. Some of them you have to add them. Some of them are kind of designed to have gravity-fed drainage systems. But any fan coil from any VRF manufacturer can either has a pump already in it, or can be made to operate integrally with a pump that is field supplied.
Yes, sir. If you have an old leaky school or building, is this still a good type of system to apply to something like that? How tight a building would you need for this to be successful?
So how tight a building do we need to apply VRF? And that's an excellent question. And what that's really asking, the thing that we're really trying to get to the bottom of is, if I'm sitting on the outside edge of my building and I know for sure I've got drafts coming in and out of the windows and brick and all of the different things that old buildings struggle against, are we going to get enough BTUs from this unit to overcome that? Or am I going to get enough? I may have enough BTUs in the room, but am I going to get enough BTUs at the window to deal with that? So probably a couple of different answers to that question. Number one, all the manufacturers have software that we can tell you, this room in this space at this given temperature, we can give you this many BTUs. We can show you airflow patterns to let you know, okay, if you put the unit here, here's how you can expect airflow to be affected from that unit. That being said, if that still doesn't satisfy your design, then it may be a situation where perimeter heat may be something that makes more sense because of the leaky nature of the building. But in our design conditions, it has been a while since we have designed buildings with electric heat backup in them. When we first started 11 years ago, it was very difficult to get a VRF system built because almost everybody in the market, us ourselves included, would design the VRF system, and then we design a completely fully functioning heat system, usually it was electric, to go in to support the VRF system, because nobody in this market believed a heat pump would be able to keep anybody warm once it got below 30 degrees outside. So we've had a lot of systems come under the bridge since then. We've learned a lot about this equipment since then. And this equipment has even improved since that time. So all of the folks that have had a chance to deal with this equipment for very long start to become very comfortable that this stuff can heat and can keep us warm in our market. Yes, sir?
You talked about you can pipe this series versus parallel.
Mm-hmm.
One better than the other, pros and cons versus those?
He asked about the HR boxes, and some of us can pipe our HR boxes in series and others can pipe them in parallel, and some manufacturers can do both. And is there any pros and cons, and are some better than the other? Well, when we looked at those two, I don't know if I can get all the way back to the screens, but when we look at those two screens that show the different layouts of the boxes, the thing that you notice is that with the layout come different configurations of how to connect these systems up. Yep. So you could imagine a scenario where if maybe this unit was right here, we had a lot of small spaces that were all kind of grouped in one central area. Well, this may make more sense. If you've got a building that kind of lays out nicely with long hallways or something like this, then maybe this way makes sense. A lot of it is, how big is the box? Do I need condensate? How many spaces am I serving from that spot? Any one of these designs where you're talking about this or this or this, it's nice and neat on paper, but when you try and envision 4 sets of 2 pipe coming into a single spot, or 10 sets of 2 pipe coming into a single spot, it starts to become a bigger and bigger kind of spaghetti factory as it all sort of veers in. So all of those things are considerations, and really it truly is a building by building question to be answered. Ms. Valerie?
Is it possible to modify an existing building using both your traditional and this, like floor by floor, or do you have to go all out one or the other?
Yeah, so is it possible to modify an existing building with this gear? And so one question I would have is your existing building boiler chiller, or is it rooftop VAV?
Whatever you want it to be.
Okay. The reason I ask that is okay, let's pretend it's rooftop VAV. So you've got a few different rooftops dealing with a few different sections of this building. This gear is very fun because you're able to start adding gear, and you can start starting up units while you still have some of that rooftop VAV operating. Then, as we know, as you start to hack off enough legs of that rooftop unit, it's not going to operate efficiently anyway, and so you're going to have to then, so that's going to kind of decide your staging, so to speak. If it's boiler chiller, you run into that same thing. You can dial those boilers or that chiller down so far, but if you're scheduling it so that you're starting the construction project either in the wintertime or in the summertime, and then you're ending that construction period kind of in those mid seasons of ours, which sometimes they're worse than the dead of winter or the peak of summer. But a lot of times planning can make it so that as you get to the inefficiencies of the boiler or chiller and need to finish that project out, you're able to do that. But that is definitely one of the appeals of this product, is that it is so modular and it can be done in such a staged fashion that it's not this equipment limiting how many stages you can do it in. Usually it's what you're replacing that speaks to that. Anybody else?
Chris, you were showing some slides that involved some energy modeling.
Yes.
Do you guys have that capability to be able to run an energy model of a VRV system versus an existing system?
Associated Air does not.
Okay.
Yeah, we depend on the engineering community to do that.
Jim, I will say, if you've got a project and you've got time working for you,
Any other questions? All right. Well, thank you very much, guys, for having me out. I appreciate it.